Hello and welcome back, guys. So in this particular session, what I'll be showing you is that what is rationalization of surds. Oops, where is my pen? Rationalization. SZ, same thing, right? Of surds. So what is this? It's basically surds to a rational number. Okay. So it's the process of changing surds into a rational number. That's what basically a radicalization of surd is. So let's see what is a surd, right? So it might be uh, under root 3. So under root 3 into under root 3, that will make it 3, which is a rational number, right? So this whole process is known as a rationalization of surds. So similarly, let's look at something else, x plus y. So in this case, what happens? X plus y into under root x plus y equals to x plus y, right? So that is a rationalization. Okay, how is that? Basically you might be thinking, how is that? Basically what happens is under root thingy square, and then after that x plus 2 square into 1 by 2, that will be basically x plus y, right? So this is how we get rationalization. So this whole process, okay, always remember process, this whole process is known as rationalization of surds. Okay, so let's have a look at conjugate of surds as well. So okay, so conjugate of surds, right? Conjugate of surds is nothing else. It's very simple. Okay, it's very simple. So what is this conjugate of surds, right? So it's nothing else but the factor that you use, this factor that you're using, to convert it into the factor that you are using. Suppose this one, right? So this was a surd, and then you multiplied it with something that's like similar surd, right? So if the factor is a negative number, or it's different from the actual surd, then it is called conjugate of surd. Okay, so let's have a look. Example is x plus y equals to under root x plus y into under root x minus y equals to x. What will happen over here? So it's basically under root x minus pi x plus y, right? So it will be basically under root x square minus y square, right? So this basically is an example. Okay, so what we did was, this is the don't look at the problem right now. So what we have to look at is basically what we are multiplying by. Okay, so this is the factor that I was talking about over here, and then the factor which is different from the surd, right? The factor, the multiplied surd, which is basically different from this one. So see the sign difference is here. That is known as basically conjugate of surds. Okay, let's have a look at few examples now. So let's say 7 under root 2 by 3. So it might be given a question like this. So it might say like, okay, rationalize the denominator, right? So what you need to do is 2 under root 3 into under root 3 into, because this is the only surd, right? So your answer will be 7 under root 3 upon, oops, so 2 under root 3 into under root 3. So what will happen over here? 7 under root 3, and then after that 2 into, why am I writing 3 over here? Because see, under root 3 will be 3, right? So 7 under root 3 divided by 6. That's pretty much it. Okay, so similarly we can have a look at another example as well. So 5 minus under root 2. So this will be conjugate of surds. Okay, in this case, if you have to rationalize this, what you need to do is basically, that's your question, right? So 5 minus under root 2 5 plus under root 2. So just multiply it. So uh, this is the surd that you have. So what you have to do is you have to multiply it with conjugate of that particular surd. Okay, so which is basically 5 minus under root 2, right? 5 minus under root 2. So after that what happens is basically this is minus minus, right? So a minus b, and then a minus b will be a minus b whole square, right? And then down below over here what happens, a plus b, a minus b basically means a square minus b square, right? Minus b square. So let's just open this formula. So a minus b whole square is a square minus 2ab plus b square. 25 minus 2.5 dot under root 2, just making it shorter so that you guys can understand. So under root 2 square, right? So 5 minus 2. So if you have any questions during until now, please do comment down below. I'll really help you out. 3 and then 25 minus, what is this? 10 under root 2 plus 2, right? So your answer will be 27 minus 10 under root 2 divided by 3. A weird answer, but still right. So this is as far as we can take it. Okay, you know what, I made a mistake over here? This one. So it should be 23. Yep, it should be 23, okay? In my book as well, I made a bit of mistake. That's alright. See, it's not about making mistakes, okay? It's about how you basically, you make mistakes, and then if you find it yourself, that's the best thing about it, okay? So it's not about making mistakes. Make lots of mistakes, does not matter. So let's have a look at something else. What should I do? Basically this problem, I guess. So 4e, okay? So 4e, let's do a bit tougher one for you guys. So let's change the color as well. Why am I using this dull color only, right? Simplify. And what we need to simplify is a plus 3 under b. And then after that, what we need to 3 under b, and then plus a minus 3 under b. Sorry about the noise, it's a bit noisy around over here. And then let's change the color again. So we have to simplify this, right? So same thing again, a plus 3 under b, and then a plus 3 under b into a minus 3 under b. So this is plus, this is negative, okay? So that's the conjugate of surds. 3 under b plus, the b is like a bit, it does not even look like a b, right? So a plus 3 under b, and then a plus 3 under b. So yeah, it's pretty hard writing in this thingy. It's not writing as if like a pen, right? So a plus b, a minus b. Should I do it? How should I do it? So let's just do directly, yeah? So if you want, I can do it thingy as well, but it's not required. I think you guys can understand. A plus b, a minus b though. So a square minus 3 under b square square, right? And then after that, a squared minus 3 under b square, a square minus 3 under b square. Is that the question? Please, but you know what? I think I have made a mistake somewhere. This should have been. Told you I make a lot of mistakes. This should have been plus, yeah. No, it should have been minus. It should have been minus. Eraser. So this is 2 again. Minus 3b. So that just means that, right? Below over here there will be a bit of difference. So since that is plus plus, okay. So below will be this one, a square minus 3 under root b whole square, and then upper will be basically a plus 3b under within the root, so that will be square, yeah. So similarly over here what will happen is this is positive, this is negative, yeah, negative, and then this should also be negative, negative. Why did I do that? Yep, that is done. After that what I need to do is I just need to clean this thing up. But yeah, that will be square, right? What did I do, man? I should have basically made this is square. A minus 3 under root b square, a square minus 3 under root b whole square, okay? So let me correct this one as well. At the top, what was that? Just this one is plus, yeah. That's it. So see, simple mistakes, but if you know how to spot it before it happens, right? So when I was calculating that, it just seemed weird, you know. So like we are getting same thing over here, same thing over here. So either you might be getting a zero answer or something like very big numbers. So right, so that was not so natural, right? So it's basically pattern recognition as well. So if you do such thing, you will be basically in good terms with your equations. So a square plus 2ab is a dot 3b plus 300b square, and then after that this will be a square minus 9, and what is that guy? 9b, right? So plus a square minus 2a dot 3b plus 9b, yeah? A square minus 9b. I just did it quickly, yeah? Same thing over here, a square plus 6a under root b plus 9b, and then I can just add this thing together because our base will be same, right? A square minus 9b, of course you guys should know about that as well. So even if you don't know, don't worry. So if the denominator is same, you can basically do the LCM like this, where you just don't need to do any kind of calculations. So cancels out. And then what do we have over here? Okay, so it's basically nothing else but we will be getting 2a square plus 9b, right? Nope, it will be 18b, a square minus 9b. Let's check our answer as well. I think it should be a bit smaller number, and this 9.2, right? 9, what was the question? 4b, right? A square minus 9b, but 12a under root. Okay, so what happened? What happened is the big question. Here's the answer. 12ab, right? 12ab. Okay, this one is good, I guess. A plus b whole square, right? So a square plus twice ab. So is that, b is that. Right, so 6ab plus, and then after that, that is basically 3b square, so which will be 9b. Not a problem over there. Minus 6ab. That seems alright as well, right? Nine b. Just looks good to me. Looks all good to me. So yeah, that should be our answer. Does not matter. So the book might be wrong as well, right? Why not? Even if it varies slightly, I'm not seeing any problem with it. Why are we getting this particular number? We won't get that number, right? In this scenario, we won't get it. Nope, that's not possible. That's not possible. So yeah, that will be our answer. So once that is also done, let's do something even more complicated. Let's do this 5c. Yeah? 5c. 6. And then within that, what we have? 2 under root 3 minus under root 6 under root 6 under root 2 minus 4 under root 3 under 6 minus under root 2. Yeah, so let's convert this 2 under root 3 under root 6 into 2 under root 3 plus 2 under root 6 under root 6, yeah. Under root 6 under root 3 plus under root 2 into under root 3 minus under root 2 under root 3 minus under root 2. So just using the conjugative surd. 4 under root 3 and then under root 6 minus under root 2 into under root 6 minus under root 2. So when you have three operators like such, what is a good practice is basically just to solve the two together and then just do the other rest together. Let's see how this one goes anyway, right? So just multiplying everything with 6. So this will be basically 2 under root 3 square minus under root 6 square plus this is basically under root 6 under root 3 minus under root 2 and then that will be under root 3 square minus under root 2 square minus and then 4 under root 3 and then you multiply under root 6 plus under root 2, yeah. Under root 6 square minus under root 2 square equals to alright, so next thing that we need to do is just multiply this thing. What the hell? Alright, let's just multiply. So 12 under root 3 plus 6 under root 6 and then this will be basically 4 into 3 minus 6, yeah. So 2 square 4, 3 square will be 3 plus, and then what we have over here, under root 18 minus under root 12, yeah. So 3 minus 2 will be 1, 4 under root 18, and then plus 4 under root 6, 6 minus 2, yeah. So this will be 6 will be common, 2 under root 3 plus under root 6, and then what happens over here, 12 minus 6 will be basically 6. So I'll just do it directly, yeah. So in the next step I can just take the common and then I will just cancel it out here. So under root 18 minus under root 12 minus 4 will be common, 18 plus under root 6 4, and then after that 2 under root 3 plus under root 6 plus under root 18 minus under root 12 minus, what is this, under root 18 minus under root 6. This guy cancels out, this guy cancels out, 2 under root 3. So they are not coming to the party, right? That just means under 3 minus under 12. So only this 2 has to go. 9.2. I'm pretty sure I must be correct. Or who knows, right? C is 0. 5C is 0. How can that be possible? 12, 12, 12, let's solve for 12, yeah. It's possible, you know why? 6, 3, 2. So that's how it is possible, okay? So for this 12, what you need to do is, you need to make it 2 under root 3. I just completely missed that. So once that is also done, everything is gone. And then all we need to do is, so nobody's going to the party, right? 0 number. That's pretty much it. Next thing that I want to do is basically this one. So if 6 plus under root 3, 6 plus under root 3 and then 6 minus under root 3 equals to a plus b under root 3. So there is a pattern that we have to match, and then based on that you find the value of, find a and b. So how is the big question, right? How do you find it? So what we will do is basically, let's just use our normal technique, 6 minus under root 3, and then let's try to match it with a pattern, yeah. 6 plus under root 3 equals to a plus b under root 3, or 6 plus under root 3 square, and then after that 6 square minus under root 3 square equals to a plus b under root 3, which is basically nothing else but 36 plus 2 dot 6 dot under root 3 plus 3. 36 minus 3 a plus b under root 3, or 39 plus 12 under root 3, 33 a plus b under root 3, right? will be 33. Yeah. So after that, what we can do is let's just break it down. No? Break it down. 33 plus 12. You see the pattern now. This is A, this is B, this is your under root 3. Okay. All you need to do is let's just solve for this. So 11. What is this? Let's just do it with 13. Yeah, 13. Let's just with 3. So 13 by 11 plus 12 by 33. Alright. Dot under root 3 equals to A plus B under root 3. So when you compare it, you can just write the language. Comparing like terms on both sides. And based on that, what you will be getting is A equals to 13 by 11, and then your B will be basically this guy over here, 12 divided by 33. Yep, that's pretty much it. Right. So we have solved this algebra. Should I do something else? So everything else looks pretty good. Everything else is pretty easy. It does not seem to be a big thing. Right. So and everything is given. So yeah, everything else is pretty easy. So that's it for this video. I'll see you in the next one. So this particular topic is done. I'll see you in the next one. Take care. Bye bye.